here thinks that the world is a little bit too disconnected from what we're doing in human spaceflight? Anybody? One person thinks that? Because if that's what you think, you're at the wrong talk. Yeah, so what about, which of you though, like when you were students, or maybe you're still students, like wish you had something kind of tangible that connects you to what you're doing in human space exploration, right? Yeah, so yes, I'm, myself and some other space engineers kind of felt that. We felt like, you know, there's a lot of like screen stuff available, information available, but so many people are disconnected from what's happening in human spaceflight. And I would say in particular, well, I'm very aware that like everyone that walked on the moon looked like this, like a white guy. And that there's so many people that still kind of have that as their mindset of who can participate in space or even in STEM in the space domain, right? So we wanted to create something that's sort of in the way for students. So this is, we call this Iss Mimic because we can tie into live data streaming from the space station and command our model to match that in real time. So what you're seeing right now is the orientation of space station at this moment. These are updating in real time. But really the point is for that connection. We also like to say that we like to trick the students a little bit because this is like the hardest Lego set ever. But while they're motivated to build it, we're kind of sneaking in some STEM skills along the way because this is 3D printed. It's an open source model, so anyone, anywhere can create it themselves. All the code and CAD are freely available. So they're learning about 3D printing. They're learning about things like Raspberry Pi. Ours happens to be signed by the founders, humble brag. We're using Arduino with coding, sensors, all kinds of technological goodness. And like there's plenty of rooms to get really frustrated and mad, and then but keep on. And then when you're done, you power through and have that satisfaction. Yeah? So I mentioned that we're using 3D models. So even these solar arrays are 3D printed, and the point of that is because we want anyone, anywhere to be able to recreate it. Any 3D printing nerds out there?
Oh yeah.
Come on, all right. So we're using PLA, right, which is baseline, because again, we want anyone to be able to do it. There's some cost there, ours warped a little bit in baggage. But yeah, these are 3D printed, then we use vinyl cut stickers to put on there. So this is what we engineers came up with, right? And we're like, hey teachers, look what we made for you. Go use this in your classroom. And the teachers are like, yeah, this is cool, but you are insane if you think we can just run with this. And this is actually the second generation, because the first generation was way complicated. And so you've heard enough from me, but one of the first teachers we brought into the fold and is now like co-leading everything we do and is now an astronaut is Amy Medina.
So when I first saw this at SEEC, NASA Space Education Exploration Conference, which is the biggest conference for teachers in Houston, it was love at the first sight. And then I talked to Bryan and said, hey, I would love to have one of these in my classroom, but the problem is it's too big. So they considered that, and they did a little one, which we call Mimic. It's half size of this, and it's easier for us in our classroom to have it, and easier for the kids to manage. So one of the things that I did was create resources for teachers. So in our website, they can access to lesson plans. We create the building guides in English and Spanish. Everything in this page is English and Spanish. So all the lesson plans, building guides are there. We also have the lesson plans are a huge curriculum designed by unit. So our kiddos, like Bryan says, they are introduced to the space station. There are some resources for NASA there that they can see, and they can be familiarized with that. And we introduce them to one of the skills that most of our youngers are learning now, and it is CAD. They learn how to design a module, how to design the station from 6th grade. And then we started with coding, because software is important, you know that, right? So we started to expose them to coding, programming the motors, and then additive manufacturing, because that's the new way. So we start with that, like Bryan said, PLA, but we have other students exploring other kind of filaments. And of course, TRR, we need to test that everything is working, so we have a unit for that. And one of the things that I really like is the how-to videos, because one of the things that you as a teacher see in a classroom is our kiddos are very visual, and they love to see how you are connecting the things. So we create that for the teachers in English and Spanish. And yes, this, because guess what? We have this kind of gap right now. Last time the kiddos connected with a teacher astronaut in space was Ricky, Joe, and Dottie, and it was back in 2017. They flew in shuttles. But right now, we are in a space revolution. So everything that NASA put there and developed, now our companies are innovating on that and are taking the lead. So now you see Blue Origin, and you see other companies that are leading the space industry in so many ways. Look at that. This is a very good example of that. So now that we are in that space revolution, they need that connection. They need to close that gap. And that's why Blue Origin stepped forward and hey, yes, we're gonna fly Amy there, and we're gonna put Amy to space so they can close that gap and see that, hey, a common person like you, like you, like you, can go to space. So we are closing that, and here I am. Because in our classrooms, middle school, we have Mars generation. High school, we have Artemis generation. And we need to start developing in the students that soft skills, that technical skills that you are so eager to see when you are recruiting someone for your company. So we created that, and that's the curriculum. We launched that back in 2023 with a couple of schools in Puerto Rico, Mexico, and United States as a pilot. And we are growing and growing and growing thanks to the support of the ISS National Lab. We have been with 2 years in a row. We have a grant, and we put this and the little ones in schools. So the teachers can teach the kiddos about space and close that gap. And now with me as a teacher astronaut, we're moving forward beyond this to start putting the kiddos to think on the next generations of spacecraft, of future space stations, because this, you know that at some point at 2030 is going to be closing. So we need to start telling the kids, okay, you have this. Now how you can apply all this and create a new one, the future one. How you visualize this. So they have the foundations and they can start creating and developing, because in a blink, these kiddos that I have in my classroom are going to be in your companies, working for you and developing the next one. So we started like that, and yeah, we have a bunch of activities for them. One of the things that we do is recreate, because when I did that, that was for SIG 2025. So we took some EVAs for Ricky and Joe, and we put it, and we started with a very big mat on the floor with this station, and we put some XRP, some little robots, to do some EVAs and fix and do some stuff. So that's the connection, but look, it's Joe and Ricky. But that time I knew that I was in Blue Origin manifest, but I couldn't tell anything because we have our NDAs. So now for next year, I'm gonna be creating something that we can close even more that gap and include something related to my flight, because we need it, we need to that. So I invite you to, Bryan, if you wanna add something, invite you to ask us questions and move forward with us and help us to put this and all the resources in the hands of the teachers, because we need your support now more than ever. We are going to have your workforce in our classroom, and it's going to be going in a 1, 2, 3. Thank you very much. You have something to add?
Yeah, I do. I mean, I think we all know that our teachers are overworked, and that we just keep demanding more and more from them. And you know, a lot of times it's a big challenge for them because people making those the decisions of what the teachers are required to do have not taught themselves. Sorry for the feedback. So I think anything we can do as engineers to support those teachers is great. And I'll just say this has blown up way beyond. So the top right corner is like kind of our original engineering team. Again, it's just to be clear, it's not affiliated with any company. It's an open source project. We're all, you know, now we have people from all over supporting this. But, you know, our dream was to bring this in classrooms, but it was not at all ready for that when we started. And what I've seen with Amy and her network of teachers, you know, teachers that can mentor teachers is really what makes it all possible.
Yeah.
And so I'm thankful to AIAA for recognizing Amy's just exemplariness, that's a word now, and then now with her, so I'm just loving that she's being vaulted, and I hope it's an inspiration to teachers, but also to us engineers. And you know, I've got kids, just supporting our teachers in the classrooms however we can, and just if we can do more and more of this, because I've seen the teachers are so hungry. I mean, they're just like eating this up, but it has to be created in a form that they can actually use, right, and fit in their time constraints. And having teachers helping teachers is fantastic.
Yeah, everything that you do to support us.
Oh, we're good.
Through AIAA Foundation, the Trailblazing Educator Award, that is an award that support our classroom with $5,000 when you won that thing. It's huge for us. It changed the way that we teach in the classroom and the resources that arrive to our school, because it's not for my classroom only, it's for the whole school. So when you have people like AIAA, Challenger Center, Blue Origin supporting that kind of projects,
yeah,
you have something marvelous, not only for one classroom, for the whole school, and go more than that, because it impacted the whole community. So you are changing the way that we are doing this in our classroom, but we need you to support us, because we are in a time that we have all the NASA educational part that is going to be impacted, and we need something else. We need something to grab. And that resources that are there in the page of AIAA Foundation, that educational part there, Club for the Future, that is the other initiative. We need something to grab so we can have the resources to teach our kiddos and move forward, because we need that. We need to do that so you have the workforce that you need, very well prepared and ready to go. And when I said ready to go, is that they have the skills to take the certification where they are in high school, the famous IBC, so they can be ready to go when they leave high school. Go with a certification, get a job, and study a career. But we need your help to do that. So thank you very much for your commitment.
Questions?
Any questions? I can ask questions about my 5-year interest too. Yeah, I can do that too. All right.
I'm going to keep throwing things until someone asks a question. No? You got one.
No, you got one.
You want
okay,
me to throw it?
Go, Katie.
See, it's a defensive move.
Go, Katie.
Hi, can you hear me? Okay, I have a question. So for public schools, they have standardized curriculum. So how do you get something like this and space in general standardized in curriculum all across America?
Well, one of the things is that when I, because mostly it's me, when I do my lesson plans, I use the NGSS, which are the standards for, nationwide. So they are aligned to the curriculum. So the teachers, when they cover earth and science or any other, if you're a CTE teacher and you are doing something related to 3D printing in your classroom, it is aligned to the NGSS. So yeah, and yeah.
There you go. Okay. So, a little bit of background. I'm a son of 2 high school teachers. So, one of the things they like looking at these things and going and giving proposals for these type of curriculums, but one question that always comes up is cost. So, if you already have like the 3D printers, let's say you have that set up, what is the cost from start to finish for something like this?
Well, for schools, we have the ISS National Lab grant,
Okay.
and we put this for free in school.
okay.
The little ones and the bigger one, which
Okay.
is Big Mimic. So we have it for free due to the grant, thanks God. But if someone has to, that's your hobby and you love to do this, we have the GitHub in our website. And you can go there, there is a bill of material and it's gonna guide you where you can go and buy the motors in Amazon or any other part that you need to get so you can assemble yours.
Gotcha.
It's about, we've been really trying to get the cost down. It's about $1,000 once you add all the pieces, the motors, the rails, all the little bits. We're really trying to bring that down, but that's again, we don't have a kit to sell. We don't sell anything. That's just, and actually we want to get somebody to create kits for us because it's complicated, especially for teachers to try to order from a bunch of places. But that's the ballpark, is about $1,000.
Thank you.
You're welcome. Katie, do you have another question? No? Okay. All right, well, thank you very much.
Let's make it move more.
Yeah.
So this is live. This is recorded data played back at high speed, just to give a feel for how it moves. So one thing I'll talk about, so we tried to capture some elements of the space station. I like to say in some ways ours is harder because, gravity. But one thing is, you have this continuously rotating mechanism, right? So for the real space station, that's obviously the case. All the power for station, as most of you know, comes from the solar panels, and it has to cross this continuously rotating joint. So if you were just to do that with wires, right, you would just twist them and then they would break. So instead, they have something like this, a slip ring. It's really interesting. I'd love to nerd out and tell you about it if you're not familiar later. But we have the same kind of thing here in our model. So there's some aspects that are challenges that are used in the station that we can show here, and you're like, oh, that's interesting. Ours was like $20 on Amazon. I think the one up there cost a bit more than that.
Now we have students from college, from Houston Community College and Cornell University that are going to be taking this and then doing some improvements. And that is what we really want to see in high schools and in the school, that they are proposing their own modifications and help the design to improve and be a little bit more friendly for the teachers. Yes? Oh, that's a fun story.
Can you repeat the question though? Sorry, the engineers.
What we connect each other. I was attending a SEEK conference at Space Center Houston when I saw this for the first time, and then we disconnect because of COVID. So my school, Odyssey Academy in Galveston, Texas, if you're familiar with this name, pretty sure you are, George Abbey, rest in peace. He was the president of our school board. So his daughter, Joyce Abbey, has this teacher externship for the teachers, things to say. So she took us, the teachers, and visit Boeing. And then we're going to see a model, blah, 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 about the station. And when I jump into that room, guess who was there?
Yeah.
That's how we reconnect.
Yeah. So, but it really did start at that Educator conference, right? And you go to those conferences and it's, of course, it's like 90% teachers, whatever, right? But they love to hear from engineers, as nerdy as we are. They really like that engagement. And so SEEK in particular, Space Exploration Educator Conference at Space Center Houston every February, they really like to team up engineers with teachers for co-presentations for that purpose.
All right. Yeah, we're good.
All right.
Yeah, we are on.
I think we started late. I think we're ahead of schedule.
Thank you. Yeah,
Thanks so much. One more for Astronaut Amy. What is it? Wait. At Astra? No. Amy Astra.
Yeah. Amy Astra.
She's new to social media, so make her uncomfortable with a lot of likes.
I'm just a simple teacher doing cool stuff in her class, in my classroom. That's it.